Hello, welcome to the video. In this lesson, we're going to be looking at section 2.4, where we're going to be solving multi-step inequalities. Essentially, what we're doing is just combining lessons 2.1 and uh, 2.2 and 2.3 together, and just like what we looked at in chapter 1 when we were doing multi-step equations, essentially the same steps we are attempting to do. We're still attempting to isolate that variable. The only difference is now we're dealing with inequalities: greater than, less than, greater than or equal to, less than or equal to. The one thing that we do have to keep in mind, especially when we are multiplying or dividing both sides by a negative number, we have to remember that we have to flip that inequality because of that change. So here, for the first example, they want us to solve the inequality, want us to graph it, just like we've been doing for the majority of this chapter. You're going to treat this just like you would have this as y over -6 plus 7 is equal to 9. You'll solve it the exact same way. So you're going to subtract -7 to both sides here, which then cancels out the 7. So now I have the y is divided by -6 is less than 2. Now, because it's division with the -6, I'm going to multiply it by -6 to make that a 1. So that gets canceled. So I'm left here with y. But recall that I multiplied both sides by a negative number. So what was less than is now greater than. And y is now going to be greater than -12. So if I want to graph this here, I got my -12. It's an open circle. My variable is on the left-hand side, like we've been talking about. And my shading is going towards the arrow, which is to the right. Looking at example B, we have 2v minus 4 is greater than or equal to 8. So in this one, I'm adding 4 to both sides to get rid of that 4. So now I have 2v is greater than or equal to 12. Because I'm multiplying by 2v, I'm going to divide by 2v to get those to cancel. So now I have v is greater than or equal to 6. I didn't have to make any change because I divided by a positive number. My variable is on the left-hand side, so that's good. This one's going to be a closed circle, and this also, my arrow is going towards the right. So looking at this one has variables on both sides of the inequality. Uh, Same idea with here, try to get them all on one side because eventually I want to have all my variables on the left-hand side. That's what my attempt is going to do. So in order to do that, I'm going to move the 2x. So I got to subtract 2x to both sides, which then that gets canceled. So now I have 4x minus 5 is less than 11. Now I can go about solving like I did with the previous examples, adding 5 over here. That gets canceled on the left side. So now I got 4x is less than 16. Getting x by itself, we must divide both sides by 4. It's a positive 4, so my inequality is going to remain the same as less than. My variable is on the left-hand side. Very good. 16 divided by 4 is 4. So graphing that, doesn't ask to, but I'll do it anyway. So this is open circle. My arrow is pointing us to the left. In these particular inequality examples, they introduced parentheses in there. So There's a couple different ways you can go about doing it. My opinion is let's distribute as much as we can to get rid of the parentheses and then go about solving it accordingly. So I have parentheses here and here. So that's under 2b plus 3. So I'm going to distribute the 4 to the 2b plus 3. So I get 8b minus 3 is greater than 8b plus 12. So again, wanting to get my variable on the left-hand side, I'm going to subtract 8b, so that gets canceled, but also this now gets canceled. So this is a unique situation where I have negative 3 on the left-hand side. It is greater than 12. So anytime that the variables have been eliminated in an inequality, we have to ask ourselves, is the inequality statement true? So we have to ask ourselves, is negative 3 greater than 12? The answer is no. So since it's no, this is considered a false statement. And anytime they give us a false statement with respect to the original inequality having variables, so if we were to choose a variable in there, there's not any variable that would make this statement true. So this particular inequality has no solution. And if they ever ask you to graph a inequality problem that has no solution, it would just simply look like this. You would just put a number line, you could just like put 0 right here, and there's no shading involved. That's how they would like you to graph it. Over here, with example B, I'm going to take this 2 and distribute the 5W minus 1s, which leaves me with 10W minus 2 is less than or equal to 7 plus 10W. All right, here I'm going to subtract the 10W to both sides. All right, this is another situation where we have the variables eliminated. So now we have to ask ourselves, is negative 2 less than or equal to 7? The answer is yes, this is in fact a true statement. So anytime we have a true statement, that means that we could place any value for W or whatever variable it might be, and you're going to get a true statement. So this is a situation where, like in the previous example A, you had no solution. This one, you have infinitely many solutions. And this one, if they ever ask you to graph it, this is a situation where you simply are shading both sides of the number line because any value would make that said statement true. So here we have, it says trivia challenge. We have a diagram over here. It gives us some scores for different games. It says you need a mean score, which is the average, of at least 90 points to advance to the next round of the touchscreen trivia game. What scores in the 5th game will allow you to advance? So you have these scores here as games 1, 2, and 3. So 95, 91, 77, 89. So in order to find your mean, what you're doing is you're simply adding up the number of scores that you've received or potentially received. And this one, they give you a stipulation is you have to have at least 90 points in order to advance. So what you're going to do here is I'm going to take game 1, that's 95, and then I'm going to add it to 91, and then add it to game 3, which is 77, game 4, which is 89, and game 5 is X. This is all going to be divided by 5, and this is a situation where you got 90 on the other side because it has to be at least 90. So it could be equal to 90, but it's got to be greater than or equal to 90 on that left-hand side in order to satisfy uh, to receive enough points in order to move on to the next round. So first thing we're going to do is I'm simply going to add up the values. So 95 plus 91 plus 77 plus 89 is I get 352, and it's going to be plus x, and it's going to be divided by 5 is greater than or equal to 90. So in this situation, both the 352 and the x are both being divided by 5. What I would advise you to do, so we're not having fractions per se, is right off the bat, I'm going to multiply both sides by 5. So this will cancel on the left side. So now I'm left with 352 plus x, and 90 times 5 is 450. So it's a much cleaner inequality problem. We're not dealing with fractions. I know fractions can be a little bit scary and intimidating. So by eliminating them any way we can, makes it easier on many of us. So now in this particular situation, we are simply going to subtract the 352 to both sides, which then x must be greater than or equal to 98. So you need a 98 or higher in order to advance to the next round. And that is being able to solve multi-step inequalities. Hope this helps. Until next time.